Hi everyone, welcome to the channel. Today the topic that I'm going to discuss about is data optimization. The sole purpose of optimization is increasing the efficiency of the pipeline we are working with. Also the role it plays in an individual's career that is working in a data related field, let it be warehousing or analytics, is immense. A person that is good at writing an optimized code and efficient code will always be the priority of the team. Now, there can be multiple methods when it comes to optimization. Like for example, in SQL, there's table indexings. In ETL tools, we have position optimization. Similarly, in Spark, also we can achieve this through several ways, like improving cluster configurations, caching, serialization, partitioning, and bucketing. In this particular video, I will discuss about one optimization technique, that is partitioning, and there can be different ways to implement it, which we will discuss later on. Now, before moving forward into the video, I would just like to request that if you have any suggestions to improve the videos, or there is a particular topic you want me to create a video on, please do mention them in the comments. And if you like the content, please do like and share it to someone who might benefit from it. Now, discussing about the agenda, as I just mentioned, we'll discuss about partitioning in PySpark and what is the best technique to implement it to create more efficient coding, and we'll touch base on these four topics. First, I'll create a partitioning of a data frame to try and reduce the total time it takes to process everything. Then I'll write a file by creating multiple partitions of it. Third, I'll discuss about data skewness that can happen as a byproduct of partitioning and how we can resolve it. Also, I'll discuss about when not to do partitioning to make sure the code you are creating is efficient. Because as we know, doing too much excess partitioning can also slow down the complete process of your data processing. So we'll discuss about how to stay away from that. Now moving forward with the video. So now let's move to the databricks and start implementing all these things. So now initially I have uploaded these two files to the databricks file system, and we are going to try create a join on these. At the same time, we'll do the partitioning and try to understand how it helps in the overall process. So first of all, let me go ahead and read these files. This is a CSV file, so we can make CSV. Also, the files have headers. I'm just going to give header as true. Also, in for schema, that also will be true. I'll just show you these files once I've done importing these. Okay, so this is just going to be join 2, and let me just remove this. Now let me show you the files, how they look. Okay, so this is the first file and this is the second one. So you can see this is the data of students who are doing majors in different subjects, and this is the overall percentage. We are just going to try and write it as an output where all of these values are combined. So that we're going to do. Also, you already know that joins are one of the most extensive tasks when it comes to data handling. So we're just going to check that. Initially, let me just go ahead and check the data in these two tables. Okay, so I need to write these to a data frame. So I'm just going to go ahead and write to this to data frame 1. And this I'll write to df2. Now let me just go ahead and show you these two. So okay, I have not run this, I guess. So now it should be good. This is the second file that's loaded. Also this file is loaded. Now first what I'm going to do is initially I'm going to check the number of partitions these files have currently. So I'll just go ahead and do that. So df1.rdd.get num partitions. Now if I run this, you will see the initial partition. So now currently it has just one partition. The same is going to be for the other file as well. Let me just check that though. Yeah, both of these have just one partitions. Now what I'm going to do is I will try to create more partitions instead of just one. and I'll write it to a new data frame. dff1 equals df1 dot repartition, and I'll create 8 partitions of this. Similarly, I'll do for the other one as well. Partition, again 8 for this as well. Just do this, and then again we'll check the partitions using this command. Now you can see this has 8. Similarly, I'll check for the other one as well. This also has 8. Now I'll just go ahead and do the joins. Now, talking about how this can help, let's talk about scenario where you have millions and millions of records and you are going to do joins. In that case, creating multiple partitions of it based on the column that you're going to be joining those two tables can be very helpful. So obviously for our case, the field that we are going to be joining it upon is going to be the ID. So I'm just going to go ahead and do repartition. Sorry, that's already done. I'm going to go ahead and join this to dff1, and I'll be joining this on the ID field. Now I need to select everything here, so I'm just going to go ahead and select everything, and then I'm going to go ahead and do show. Now you can see this is giving everything that I need. Just let me fix this truncate here. See, once I have joined these two tables, I am getting all of these values combined instead of just them being separated. Doing this, the process gets a bit quicker. You can see it just happened in 1 second. Now let's talk about scenario as I just mentioned. In case you have multiple millions of records, then doing this will really help you, but you need to be very careful as to not create too many partitions, because these all things are going to run parallel, and if you create way too many partitions, it is again going to impact the code running speed. Now with that, this part we've already covered. Now I'll just go ahead and try writing it to a file, and I'll try to go ahead and do partitions there. Now I'm just going to go ahead and write this data frame to a file. So let me start with that. dff. I'm just going to write the initial file only, not the new part that we have created. Write dot format I want to be in CSV only, and I want to keep the mode as overwrite. I don't want to create new files every time. And then my header was available, so I'm just going to keep it as header is true, and then I'm just going to go ahead and save this. Saving, I'll just take the name from there, initial part, and then I'll just change it a bit. I want to create again a new folder here where I'll keep the name as partition, and I'll give this name as just file.csv, and I'm going to go ahead and write this, and this should be fine. Yep, this is fine. Now what I'm going to do is I'm going to check the amount of partitions this file has created as of now. So for that, what I'll do is I'll use the dbutils.fs.ls command, and I'm just going to paste this file name here. See, initially it just has one file. Now let's say the amount of data that we have is way too much, and I want to write it as multiple partitions to reduce the time. What I'll do is I'll just go here and add repartition. I'll define the amount of partitions that I want. For example, I want just 4 partitions as of now, and I'll run this again. That is done. Now let's again check the amount of partitions that we have. Yeah, now you can see the total partitions has increased. Now we have 4 partitions as we should be having. Okay, now was one of the methods that we can increase the partition while writing the files. One more method that I'll discuss about is doing partitioning by. Now the difference between these two is, in the repartition you can only define the amount of partitions that you want, but in partition by you can also define the kind of based on the fields. Now for example, if I go up here, you can see, now let's say I want to divide it based on the majors. What that will help is, let's say in future I only want the data of the students that are in the mechanical engineering branch, or just the civil engineering, I don't want the overall data. Then in that case, creating partitions based on a column will be easier for me, because after that I'll be easily able to pick these details from there. I won't have to read the entire data, I can just read that particular partition. So let me just go ahead and create a partition on major. I'll just go ahead and create the partition on major. Oh sorry, I need to keep the slash here as well. If I run this is done. Now let me quickly run this again, and you'll see there will be partitions based on the major here. Yeah, you can see it has major of electrical engineering and mechanical engineering and civil engineering. See, so now later if you want to read data for just these particular things, you can do that as well. Yeah, now after this, as you can see, these two are discussed. Now we'll just go ahead and discuss about the remaining two. See, one of the issues that can happen is data skewness because of partitioning. What actually happens is, when you are creating partitioning, let's say for example I have created the partitioning by major here, right? Let's say the amount of data for mechanical engineering was way more compared to the amount of data for civil engineering. In that case, what will happen is, the data in one file will be way more compared to data in the other files, so that can cause a bit of issue. So in order to kind of handle that, what we can do is, we can create one more option here, and this option will decide the amount of records per file that you'll have. So the command is max, sorry I have no sorry, max records per file, and I can go ahead and define that. Let's say I'll go ahead and say 2, now if 4, and if I run this, it not a single file will have more than 4 records per file. You can obviously change this based on the requirements. Also, it is not a good practice to keep this much records, because keeping this much record, if you keep the number of records very low, again it will increase the amount of time that it takes, and that is obviously not advisable. Until it runs, let's go ahead and discuss about the final part of when to do partitioning and when not to do partitioning. Okay, I have not given the end, this one here, let it run. Meanwhile, we'll just discuss about the ending part. See, the reason people are moving to Spark it is very fast compared to the previous big data tools. So if you go ahead and start creating partitions when the number of records is very less, let's say 10,000, 20,000 record, it is kind of redundant. So going ahead and doing partitioning only in the case where the amount of data is very huge only will give you a significant difference in the amount of time load. And if you go ahead and create a lot of partitions, it will again cause issues for you. So that is not a good way to implement this. The ideal way to implement is kind of understand the amount of total records you have. Let's say you have 1,000,000 records, creating 4 or 5 partitions should be good enough, because Spark in itself is very fast. Yeah. Also, you can see this is already run. So if I go ahead and check this, you'll only have 4 records per file. It will not exceed more than that. That will be all for this particular video. If there is anything that I missed that you want to add on, please go ahead and do that in the comments. I'll make sure that I'll take the feedback and improve it. If you do like the content, please go ahead and like the video, share it with the people that can use it. Thanks for watching the video. Goodbye.